Okay, we have here today another integral. This one's from Caltech Math Meet 2025, finals number 16. We have the integral from 0 to 1 of this whole thing here, dx. Okay, I know I've done integrals like this a few times in the past, and it reminds me there was one in the Berkeley integration bee. I think it was 2020, and there's a video somewhere on YouTube where both contestants did the problem in like 1 second. And so even though I can't tell you exactly what method they used because they did it in their head, we're going to try to recreate that here. The one thing I definitely can recreate is putting down the answer. They just went immediately put down 0. Now, to some extent, they could have just guessed a 0, right? Because we wouldn't know. You're allowed to guess for the most part on an integration bee. I'm just going to do it out and see how I think it should work in order to do it really fast, maybe a second, maybe 10 seconds. So first of all, what I'm going to do is just change this minus sign. We can use this to split this up into two integrals. But I did it a strange way. I actually changed the sign and used the negative sign to flip the bound. So now this one's going from 1 to 0. The reason for it is, let's consider this function right here. Let's think of this as f of x. And we have our bounds that we'll call a and b. And now if we plug in to get first like our f of b value, so we look at f of 1, and you just plug in a 1, you're going to get 0, of course. And then if we do same thing for 0, the lower bound, if we look at f of 0, or f of a, that's going to be 1. So we have this property here. When we take our b and we get f of b, we get this 0 right here. And if we take this and we get our f of a value, we get this 1 right here. So the key idea for this whole thing is we need this other function to be the inverse of this function. This is how it's going to work. So we want this to be f inverse x. And so when I said before that they might be guessing, that probably is the part where I'm thinking you could kind of guess, because you just look at it. Maybe you don't really do it out, but you say those kind of look like they could be inverses, but we'll do it out. So I'm going to set this, our f of x value equal to y. And then all we need to do to determine if they're inverses is just solve for x. So first thing we do is take the 20th power on both sides, and that's going to clear it on this side. And then we'll solve it for, just rearranging it, we get x to the 25th equals 1 minus y to the 20th. And then I can take the 25th power on both sides. So doing that, we isolated our x, and we'll write it in this kind of notation. So we have here 1 minus y to the 20th to the 1/25th. So if you switch the variables back, put this back to x, you get exactly this right here. So that shows that these are inverses. And so with that information right there, we're ready to use a formula and finish this thing off. Okay, so we have our formula for dealing with inverses right here. Notice we've already shown that this is all exactly set up. Our f of a, our f of b, everything is lined up. So we can go right to this answer. And the way it works is basically just multiplying the bounds the way we have it here, because we have b, f of b, a, f of a. So all we need to do is plug in, and when you do it, you get 1 times 0 minus 0 times 1. Multiply that out, and of course, we get our final solution of just 0 on it. There's a few other ways to look at it that might make it go faster in your head. Like, first of all, if you could visualize the graph, whenever you have two inverse functions like this in between 0 and 1, this setup basically, I mean, this is everything we did here, but whenever you have that setup, a lot of times it's going to be between 0 and 1. What's going to happen is the area under the curve is going to be the same for both of these functions between 0 and 1. If you put it back, when you're subtracting those two, that means it's always going to subtract to 0. So you could think of it that way. Another way to think about it after you somehow verified that these are inverses is just multiplying the bounds like I have it here, because that way it's pretty clear to see that you get zeros without having to write out the formula and go through this stuff right here. Anyway, that's it for today. Thanks everyone for watching. Have a good day.